This is problem 8.1 from Brigham and Houston's Fundamentals of Financial Management, Concise 9th edition. You're given some information about demand for a product under these 5 different states of nature and the probability of each of these occurring and the rate of return for the company if these are the outcomes. For instance, if it's weak demand and there's only a 10% probability of weak demand, then they'll lose 30% on this. On average, which they think about 30% probability that they'll have an average demand, they'll earn 11%. Above average, there's a 30% chance it'll be above average, they'll earn 20. And if it's a strong, and there's a 20% chance of that, or a probability of 0.2, they'll actually make a lot of money. Calculate the expected return, and the expected return is the weighted average return. You get a weighted average by multiplying probability times the outcome. So if I take the probability times the outcome, that would be this times this, and then add them together, I'll have the expected return. Okay, so when I add all these together, that's the expected return, 13.9%. Now, if the probability of each of these occurring was exactly the same, they're equally likely, I would have just taken the average of these numbers. But note that there's only a 20% chance that it'll be either weak or below average. The highest probability is it'll be average or above average. Okay, so since these numbers are different, you have to use the weighted average approach to put the appropriate weight on the appropriate outcome. All right, to calculate a standard deviation from this mess, the next step is to take mean deviations. And the mean deviation is simply the outcome minus the weighted average outcome. All right, so for each of these, I'm taking a weighted, I'm going to subtract the weighted average from each of them. And now I have the set of differences from the average. Okay, so mean deviation different from the average. To calculate a standard deviation, I want to square the mean deviation. That'll be simply that raised to the second power. Do that for each of these. And then take the probability times the squared mean deviation. This times the probability. Add those together and I have what's called the variance. Alright, to get the standard deviation, take the square root of the variance, raise it to the 1/2 power, and that's your answer for your standard deviation. So there's your mean. The mean expected return is 13.9%. The standard deviation is 21.9%. Okay? So mean and standard deviation, or expected return, or mean return, the coefficient of variation is the standard deviation divided by the mean, okay, or expected return. So if this is 13.9 and this is 21.9, then the coefficient of variation is the risk, standard deviation, divided by the expected return. Alright, and this is not expressed as a percent, it's generally expressed as a number to less than 14 decimal places. It's just an Excel foible. Alright, so the coefficient of variation is 1.57. 1.57 units of risk for every 1 unit of expected return. The lower this number, the better.